Hi guys, so let us continue with the optimization. So basically in our last submission that we did, we got a time limit exceed and we passed 32 cases. But I think the reason is because they have not mentioned any constraints on the length. So let us try to compute the rough estimate of our time complexity. So initially this function is taking order of n. Let us assume that n is the number of strings in the word list. Now this function is taking order of n square, but order of n square multiplied with, so we need to check between two strings if the path exists, right? So all the strings are of same length. Let's say the length of all the string is k, right? So n square k is the complexity over here. N square k is the complexity. Now in the case over here, we are trying to travel each and every node in a level order traversal manner. While doing so, the complexity over here would be order of n itself, but we are also multiplying the parents. I think this n square k, is it needed? So can we optimize on this end? I think if we won't do this, then we have to do this inside the queue, wherein we can push the starting index and then we need to loop over all the possible choices that we have. And if there is a path difference, then we can say, if there is a if the path exists between these two words, then we can say okay, then we can go to that word. So let us try with that approach. Let us say we are not creating this adjacency list, but we need this line if the path exists. Right. So what we will do is we will bring this down, and instead of this line, we have to check another line. So what will be that line we are writing over here? So let us say for int I equal to 0, I less than n, I plus plus, so that if line will come over here. So this is the index tp and this is the index I. So before checking this, we need to also make sure that the element that on which we are trying to go, right, either it should satisfy certain conditions, right? So let us see what those conditions are. First of all, the element on which we are trying to go, um, it should be either visited in this array, or either it should be visited on this array, or the parent of that particular element should be empty, right? If these two conditions hold, either of these condition holds, and if the path exists between the words, then we can say that we need to operate this line, and this line, right? Then we can say that we need to operate these three lines, and okay, also we need to take care of this line before only. So we will indent it better. And okay, so indentation is perfect. So and this will eliminate all of these choices. So this is the end of. So let's say this is the end of the for. What is this? So this is the end of this for loop. So this should be the end of the if loop, and this should be the end of the for loop. Okay, and this should be the end of the while loop, and this should be the end of the outer while loop. Yes, and once if next exists, if next, so we will come to know if net is next exist once we are done with this while loop, right? Yes. Then what is this then? I think this is redundant. Let us see if this is passing or not. There might be some indentation errors if we have done something wrong. Then we will get to know about it. Okay, so what is this child? Okay, yeah. So this is I now. Okay, so what instead? Yeah, this is I. Let us say this is J and this child is I. This is J. This child is I. Okay, so one thing we will push only if it is not visited, right? So this will also reduce our time. If visit of I is 0, then only push I, and this should be done after this line. Let us see if there are any improvements in the time limits or okay, so now it is failing at a different test case. Let's see it is less than 32 or greater than 32. Okay, so it is less than 32. In this case, they have passed only 30 test cases, but over here they passed 32 test cases. As expected, this is more slower as compared to the previous versions. Okay, so this is needed indeed, right? And over here we should make it for int I and add the sense of TP. So this condition we not have to check again and again. Okay, so let me know one thing. Like this BFS approach is giving TLE, right? So instead of storing the indices, what we can do, so we have one string and from this string you need to go to many other strings and you have set the path. I think let us check the discussion section to know what is the approach. Double-ended level-wise BFS. Double-end level-wise BFS. Python BFS keeping parent pointer. I think this approach of using parent pointer is what we are doing. Fairly slow but fairly memory efficient. So BFS plus TFS. This is what we were trying. Okay, this is great. Everyone is doing BFS and TFS on this. Let us check this BFS solution. They are pushing the entire world. They have not even calibrated the adjacency list. So they are also doing level-wise traversal. For string in visited, I will erase in. Okay, so they are using this technique to optimize the code. So what they are doing is, let us try this on our case and let's see if we are getting any answer or not. So what they are doing is, let's say we are having an unordered set of string which is visit, right? So what we are doing here, they are also doing the same. Um, Visit, comma, all, right? And so all, now in this all we have all the list world, right? Now, so this is S which denotes every entry which is possible. So now for string in visit, so in each level what we are doing is we are erasing this string as t. So now if the string had been visited earlier, then it would not be present, right? It would not be present. So what we need to check, instead of these two conditions, we just need to check one condition, if this string is present in S or not. If yes, then mark its visit as true. So what we will do, so if s dot find, so we can do this in with indices as well, right? So we do not need list, so we can quickly fill. So int I equal to 0 and less than n and plus plus s dot insert I. Now we can see that if s dot find I is equal to s dot end, if that is the case, is not equal to s dot end, then what we will say, visit dot insert I. Now once this level order traversal is done, what we can say, all the indices int which is present in visit, you erase those from S. So will this optimization be helpful to us? Let us see if this helps to us. Let us see if this passes or this shows TLE. Okay, so it is also showing TLE on test number 33. It is passing 32 test cases. Okay, so let us continue looking at the submission, looking at the approach what that guy did, because we also are almost doing the similar thing, but there is something extraordinarily important for us to learn. Okay, did we clear visit? No, oh shit. So over here we forgot to clear the visit. See, in first our solution took 4 milliseconds to run when we did not clear visit. Once we cleared the visit, our solution is just taking 0 millisecond to run. So that is the drastic change over here. So I think it should, okay, it is again giving TLE. Yeah, so let us see what this guy did ahead. So yeah, they applied the level order traversal. So okay, they are storing the entire string in the queue. So they are storing the so they are doing BFS, but they are doing BFS on the path. So what is the meaning? Meaning is meaning is they are doing level order traversal, but they are doing the level order traversal on the path. That means then the not. So this is the meaning. I think. Oh, I guess I will be able to implement it quickly. So yeah, what we did is we tried to say, okay, we are making the, so we do not need this parent, I guess, now anymore. We just need the string, I guess, over here. S should contain all the strings in the word list. So this line is also not needed. Now, for string that is in the visit, you erase that from and make visit. So now this is also not needed. Is next why. So yeah, what we need to say is now they are applying vector of string. Now let us say this is the current path, right? So currently we have only the beginning word. Now this is the current path. Now we popped out the current path. Now from this current path we know what is the last word, path dot. So in adjacency, so basically create, instead of creating the adjacency, what they have done is they are checking for each and every character, right? But they are checking it in an optimized way. I think yes, why they are taking the advantage of this fact that you all the words contain only lowercase alphabetic characters. So what they are checking is not like this, so we do not need adjacency list as well, right? And now the way in which we will check, we do not need this adjacency list. So I think we should write this entire thing again. So the point is we got the path, right? So let us say the string that the bag dk is nothing but path dot bag, right? This is the last word in this string. So now what we want to do is for in, okay, yeah, for character as equal to a, no, not as, for character p equal to a, p less than equal to z, p plus plus, right? For uh, character equal to 0, I less than size I plus plus. What does this mean? That what does this mean? That for the current string, what we are doing is if the character which is present at the ith string is equal to p, then you just continue. And else what you check if, so else what to do is you make bk of I character. Org will store the original character which is bk of I. Now what we will do is we will make bk of I is equal to p, right? And if now after modifying this bk, if we are able to check if s, which is the set of the strings which have not been visited so far in this level order traversal, if s dot find bk is equal to s dot end, is not equal to s dot end, that means we have a string which is of this kind, right? So once we have this string, once we have a string of this kind, what we can do, we can add it to the path, right? So we can say q dot push. First of all, what we need to do is we need to say visit dot insert this string which is bk, and next thing that we need to do is we need to say q dot push. Okay, so first of all, we need to push it to the path. So let us say we are making a new path, vector of string and p, which is new path. And now we are saying and p dot push underscore tag. Now we will push pk into this. So this is the new path, which is the extension and the next level. So now we will say q dot push. Now we will say you just push this path, right? So how we will know that we need to break? So if bk becomes equal to, every nodes whether we found the string or not, right? So let us say in one change we got this, and let us say if this string that we have found, if this is equal to the word which we are searching, then yes, we found out the string. Yes. Then all the paths which are present in the queue, then if will be the part of the answer, right? Because once this gets complete, we need to remove everything from the queue, right? We removed everything from the queue, and then if every is true, then we just break. If we break out, all the parts which are present in the queue will be the part of answer, right? So let us say while not of q.md, we, if, so let us say vector of string path is equal to q dot front, and this is q dot back. Now if path dot back is equal to the word which we are searching, that means this is the path to the answer, and then we return this. So in this way we can apply bfs on the path. Line number 30, q dot push. Okay. Yes. Let us see if this passes or not. Q dot push dk. Okay, so this is wrong. Q dot push. We should push the new path into the queue. So we are not getting any answer at first. What is this BK? Yeah, this is the. Okay, I think in after this BK of I should be restored, and it should be restored to its original character, which is org. Now I think it is passed. This. Let us see if this passes this or not. We have already made it 5 TLEs. So now we have passed the solution. The trick was to apply BFS on the path and not on individual streams. And the another trick was to optimize the way in which we are finding the next string over here, right? So what I did was I took the last string of the path, and then from every character from A to Z, I just made that character for every character, and at every position I just changed the character over here to that character, and then I just checked if the new string which is formed by changing one character is present in the unordered set or not, right? So in this way, I think it was a difficult problem to think because BFS on the path is something that is not quite common. So yes, with this we end the second part of the word ladder 2 problem. Hope you guys enjoyed it.